are looking at activity sheet 4. Please remember that the number right there is the activity sheet that we're on. And we're looking at dimensions in media, meaning like TV screens, movie screens, things like that. So the first thing I want you to do is I want you to think about your graphing calculator screen. Is it a square? No, it's not. But when you have the grid that goes to 10 on both sides, what it does is it squishes your image. So you might wonder, if you're ever pulling your calculator out, what does zoom square do? So on a normal graph, it looks like this. But if you went to zoom, and then this option 5 down here, it will actually square up your window so that the hash marks are the same on the up and down and the horizontal. Okay, if I go back to zoom standard, which I normally have, I want you to notice that there's a wider gap between the left and right ones on the x-axis than there are on the y-axis. So that's what we're talking about here, is aspect ratio. And to talk about this, I want you to know, first of all, how we look at TVs. When you are given TV dimensions, I hope that you know you're looking at the diagonal. Not everyone seems to know that. So if I have a TV, and if it's like a 42-inch TV, it's the diagonal. And what's happened over time, obviously this is like the one you might have your grandparents' house. This is what we have now. The old ratio happened to be something that was super tiny. And I'm going to bring an old friend from your geometry days back in. Are you ready? Are you ready? Who is that? That's Pythagoras! Pythagoras is back. And why in the world would we need to know about him? Well, Pythagoras is super helpful to us as we try to think about this old Pythagorean theorem. Pythagorean theorem is what allows us to solve and write triangles. So when I take a look at a triangle, I used to have a very famous Pythagorean triple, the 3, 4, 5 Pythagorean triple. And if you remember something, in a triangle, if you talk about the sides, one of them is A and one of them is B, and the hypotenuse is C. So there's A squared plus B squared equals C squared. Guess what? It's back. So if I had 3 squared or 9 plus 4 squared or 16, that happens to equal 5 squared or 25. And that's important for us looking at televisions. So thank you, Pythagoras, and we're going to be using him today. So in your problem that you have here, it states that the size of old televisions is the length of the diagonal of the screen in inches. So that's what we're looking at right here. The aspect ratio of the screens of older TVs is 4 to 3. 4 to 3. Now I want you to think about that. That means 4 to 3 ratio, just like this. What? Pythagoras knew all about these old TVs, right? So if this is 3 and this is 4, this is 5. They're proportional. Now think about, how do I get 25 out of 5? What is it that I'm multiplying by? I'm multiplying by 5. So if I'm multiplying these sides by 5, 3 times 5 is going to give me 15 inches as the height of that TV. 4 times 5 is going to give me 20 inches as the width of that TV. So the width and the height of this old TV are given here. The width is 20 inches. Sorry, that's supposed to be a 2. The height is 15 inches. And if they ask for the area, we know the area of a rectangle we get by doing length times width. So we'll just multiply the 20 times the 15, and we'll end up getting, sorry, I'm going to get my numbers in there, and we'll get 300 square inches. Now, how you want to say that is up to you. You could do inches squared. You could say the little SQ for squared inches. Sometimes people like that. So that's old TVs. Maybe you want to circle on this one. This is an older TV here. Now, take a look at the newer TV. Oh, gosh. It says repeat this process to find the width and the height of a newer 48-inch TV whose aspect ratio is 16 to 9. This is what we have in our homes now. So 16 times some multiplier, 9 times some multiplier is going to give us this 48-inch TV. Remember that TV length is measured on the diagonal. And guys, here's where the algebra comes in. We need to take 16x squared. We need to add that to 9x squared. Right? A squared plus b squared equals c squared. And that's going to equal 48 squared. This is definitely calculator work. I'm gonna square 16 and get 256. I'm gonna square 9 and get 81. And the good news is, since I'm combining like terms here, every single problem we do, you're gonna see the number 337. On the right side, you have a larger number. And again, if you're forgetting or wondering where they're coming from, just have your calculator out and make sure you're doing the arithmetic and follow along there. So there's your 2304. So what I need to do is, if I'm solving for x, I need to divide by 337 and then square root it. So to the calculator, I take this number, I divide by 337, and then I want to square root my answer. So big old square root, oh my goodness, it's in there. I like to use the previous answer that's down by the negative sign. And what I come up with is this multiplier. Now this is kind of an interesting thing to do calculator-wise. What I have is a number that's not clean. So I get something about 2.6, and what I indicate in my notes, I put 3 dots if it's not exact. So I'm going to get on the calculator and I'm going to show you something kind of cool. If that 2.6 is your last number, I'm going to store that as x. What I can find then is what the width is, 16x, what the height is, 9x, and if I wanted to find the area, I can have the calculator do that all at once. And what I'm not doing here is I'm not rounding. So the area is 984.5 square inches. So I'm going to pull change my pen color just to fill in the area numbers on this one. Here, I'll go blue here. So my 9x gave me 23.5 inches. The width there was 41.8 inches. And then the area was what I got when I multiplied those together, but by doing it in the calculator, I didn't have to round. I got 984.5. Now don't say it's inches, it's area, so it has to be inches squared. So if it were me and I were taking calculator notes, and I think this is helpful sometimes, I would indicate that I go through and I get my work, and then I want to store. That's supposed to be like a little triangle that comes out there. So you're not going to see any work, but it's going to be held in the calculator. Then I can do 16x on the calculator. It gives you that 41.8 number. Tens place is fine. If rounding's ever important, I will definitely let you know. And then also remind yourself you can do the whole area one of 16x, 9x all at once. That's where the number 984.5 came from. Okay, so what I do, if I'm doing calculator notes, you'll see me do this kind of archy thing. To me, that's representing the calculator screen. So that's really the big problem today, number 3. But then they have some images on your notes that I want you to look at, if I can get there. Okay, you have old TVs and you have new TVs. If you flip your notes over to the next page, you're talking about 2 terms. One is letterbox, like you would slide an envelope into a mailbox. The black bars show up here. And if I have something called a pillar box, think pillars are like vertical, that's when the black bars are on the side. So if you're looking at the picture of the zebra, that's called letterbox. If you're looking at the picture with the peacock in there, that is called pillar box. So think like pillars on a house. Pillars are tall, almost like columns. Letterbox is you're like taking something and you're putting it in a mail slot. That's what they picture this to look like. So on the back, it just says, when movies that were made in one aspect ratio are shown on televisions that have a different aspect ratio, black bars of equal width cover a portion of the screen. Sorry about that. Portions of the screen are not needed to project images that were created with different aspect ratios. So this is an old screen with a new image. I just think if you can annotate a little bit over the description of those, it helps. This is a new TV, a new screen displaying an old image. So this is like if you were watching those old TV shows, that's what you would see as the black bars on the side. Okay? So they do have a question here with percent. I'm not gonna drive us too crazy. If you want to figure out how to get 75%, great, but we are not gonna go that far into it. So the takeaways, there's some language. Again, this is called pillar box. This is called letterbox. And the next time you're watching TV, maybe you can find some old TV shows on your new TV and they'll look like that. Have fun.